Now let's look at unitary equivalence, which is actually something which is similar to what we had, like similarity. So if B is similar to A through a unitary matrix, then A and B are said to be unitarily similar or unitarily equivalent. So what I mean here is, if B is similar to A, we can write B is equal to S inverse AS. But it's given that the similarity is through unitary matrix, right? So I mean, let's write it as U inverse A into U, right? But this U matrix is unitary, so inverse is same as the Hermitian. So this is same as U Hermitian U. So in such a case, we say A and B are not just similar, they're unitarily equivalent. Okay. So there is a very important, very interesting thing about, we have seen the properties of similarity, where the characteristic polynomials are the same, the eigenvalues are the same. Also, we've seen that the rank of both the matrices are same. All these things we have seen. But if it's unitary, it also has another property, which is the L2 norm, which is in fact the Frobenius norm. Frobenius norm of A is same as the Frobenius norm of B. What does this mean? So this means, what is the Frobenius norm of B? You basically, this is the Frobenius norm, okay? Let's recollect. Or all ij equal to 1 to n aij squared. Right, this is the Frobenius norm. Also, this is equal to trace of, this is A, and trace of A Hermitian B. This is root. This is squared, okay? Fine. So the Frobenius norm can be also written in terms of the trace of the matrix A Hermitian. So we'll use a similar result here. Frobenius norm of B2 squared, B matrix squared is equal to a trace of B Hermitian B. Yes. So B can be substituted as U Hermitian. B is equal to U Hermitian AU. You substitute here, you'll get U Hermitian A, U Hermitian into A into U, the trace of this, and U into U Hermitian is equal to I. And you get U Hermitian, A Hermitian A into U. And trace of AB can actually cyclically rotate, is equal to trace of CAB equal to trace of BCA. We can actually cyclically rotate the trace. So if you cyclically rotate, U comes here. So this is U into U Hermitian, which is again equal to I. Is trace of A Hermitian A, which is the Frobenius norm of A. So if two matrices are unitarily equivalent, their Frobenius norms are equal. So that is an interesting property. If you add, take the squares of, you take every element, square it up and add it together. Similarly, you take another matrix and square it up and add it together, both will actually be equal.